All right, so I'm going to be going over a few different problems from a packet. I'm going to post a PDF online. If you want to print it out to go along with it, you might find that helpful. I think, graphing it by hand on your own is definitely going to be a helpful exercise. So if you can do that, please do. But, if you don't have a printer at home, you can use graph paper and, of course, follow along with the video. Okay, so for all these, we're going to graph them, all the piecewise functions. We also have to identify if it is a function. Is it going to pass the vertical line test? Then evaluate the graph at any specified domain value. So they want to know what's the value of y when x is 3, when x is -4, when x is -2. Use a function table for the boundary condition. So they just mean like an in and out table. Okay. All right, so the first function we have is f of x, and the first part of the piecewise is x plus 5 when x is less than -2, and then -2x minus 1 when x is greater than or equal to 2. So what I like to do is I like to call this A and B. I'm going to make two tables, one for A and one for B. Okay, so I know this is x is less than -2, so -2 is going to be the last thing I plug in. I'm going to get a few dots, few coordinates, I should say. And I'm going to make sure I know that it's an open circle here when I plot this, right? Because it's not including the domain at -2. B starts at -2. X is greater than or equal to -2. Oh, oops, I made a big mistake. These are all x values. 0, -1, -2. That'll be open circle right there. And then for this one, we're going to start at -2. I don't know how many mistakes I'm going to make there. Sorry. If we're less than -2, it's -2, -3, -4 going in that direction, right? Here's the line, the dividing line, x is -2. All the way to that left side is going to be our A function. Then B is going to be all the values greater than -2. So we're going to start at -2, go -1, 0, 1, 2. Really actually don't need that many. Since they're both linear functions, 3 dots should really be enough. All right, so now I'm just going to plug it in. When I plug in -2, I get -2 plus 5, or just +3. Then I plug -3 in. I get -3 plus 5 is +2. I plug -4 in. -4 plus 5 is +1. So now I've got 3 points I can plot. -2, 3 is my first point. Now I'm going to put an open circle there. -3, 2, and -4, 1. So that should be enough points for me to get an idea of what this function looks like. I can see my slope is -1. And that's continuing indefinitely, so I put an arrow because it could go on forever. Now for this one, our function is -2x minus 1. So I'm going to plug -2 in first. -2 times -2 is 4. 4 minus 1 is 3. -1, plug in, I get -2 times -1, that's equal to +2, minus 1 is 1. And since my slope is -2, I know it's just going to keep going down 2 every single time. All right, so I'm going to plot my first point here, -2, 3. So actually this point is going to be filled in because this exists for this function here. Then I have -1, 1, 0, -1, and I can see my slope is down 2 over 1, so I can just sort of follow that pattern. All right, so is it a function, yes or no? Does it pass the vertical line test? And yeah, it does. It never hits the graph twice, always only once. So it definitely passes that. All right, f of 3. So that means what is the value of the graph when x is 3? And I can see that it's going to hit, let's see, 1, 2, 3, 4, 5, 6, 7. So that y value here is -7. When x is equal to -4, 1, 2, 3, 4, y is equal to 1. When x is equal to -2, y is equal to 3. So that's just number 1. Okay. Number 2. F of x is equal to 2x plus 1, and then 1/2 x minus 3. So I'm going to do the same thing. I'm going to make 2 different tables. Let's call this A and B. I'll do my table for A over here. So for A, it's x is greater than or equal to 1. So I'm going to start at 1 and go up. And I know I'm going to have a filled-in circle for this first coordinate. Plug in 1 to the function. 2 times 1 is 2. 2 plus 1 is 3. 2 times 2 is 4, plus 1 is 5. All right, my slope is up 2 over 1, so I know these are going to increase by 2 every time. So I can get 7 there. And I'm going to plot those 3 points. 1, 3, 2, 5, 3, 7. 1, 2, 3, 4, 5, 6, 7, 8. Good. 1, 2, 3, 4, 5, 6, 7. All right. Great. So I can extend this line. All right. Now let's do function B. We want x to be less than 1. So I'm going to start at 1 and go down. We're going to have an open circle there. When I plug 1 in here, 1/2 times 1 is 0.5, or 1/2. 0.5 minus 3 is -2.5. Plug a 0 in. 1/2 times 0 is 0. 0 minus 3 is -3. And this is going to continue to go down by 1/2. But I can just plug -1 in to make sure. -1 times 1/2 is -0.5. -0.5 minus 3 is -3.5. I know it says the slope is positive 1/2, but if we're sort of going in decreasing order here, backwards. If I were to read the x in the right order, right, -1, 0, 1, you can see it's going up by 1/2 every time, so that slope is consistent. So the first point we're going to plot is 0, -2.5. I'm sorry, 1, -2.5. 1's my x, -2.5 is my y. I'm going to put an open circle there. -0, -3. -1, -3.5. And we can see it's going up 1/2 over 1, or up 1 over 2. So that slope is consistent with what they told us. All right, great. So is this a function? It's a little bit different than the one we just did because they don't share that point. They don't overlap, but you can still do the vertical line test. And even though it sort of looks like right here, it hits the function twice, we have an open circle and a closed circle. So really, there's only one value. So I can say that yes, it does pass the vertical line test, so yes, it is a function. F of -2, if I go to -2 on the x, I see that this is equal to -4. If I go to 6 on the x, 1, 2, 3, 4, 5, 6. So now I'm in a situation where I can't use the graph to help me. So I need to go to my definition of the function. So if this x value is 6, I want to choose the piece that has the domain of when x is equal to 6. So I have x is greater than or equal to 1, or x is less than 1. Well, 6 is greater than or equal to 1, so I'm going to use this top part. So I'm just going to plug it in. 2 times 6 is 12, plus 1 is 13. F of 1, well, I want to choose this top one, because that's the filled-in circle, and that's equal to